Hi everyone, welcome to this new video. My name is Aditya, and on this channel I talk about Kubernetes, blockchain, and software engineering in general. And in today's video, we are going to take a look how we can build a Kubernetes operator that works similar to GitHub Codespaces. So let's take a quick demo like what we are going to do in this particular video. So here you can see that this is a VS Code that is running on a browser. This is running in a browser, and this is very similar to what GitHub Codespaces also do, right? So this is a developer environment that you can spin up in the browsers, and using this, like, you can spin up the various developer environments according to your needs on the runtime, right? So this particular setup is right now the one that you are seeing on the screen. This is using Golang as a backend or as a platform. But similar way, we can configure Node.js environment and Rust and Python as well, right? So I'll just quickly create a file here, and I'll create a simple Golang program, and we will be just running this here itself. So I'll create a file called main.go, and inside this, let me just quickly do it. Let's run this. So here you can see that we are having a dedicated terminal as well. So from here you can run the commands as well. So this developer environment is configured to use Golang. Along with this, it is also configured with a database as well, which is Postgres in this case. And this was, I'll show you how I created this with the help of Kubernetes operator. So let it run. But meanwhile, let me show you the environments, the configuration. So here you can see that this is a custom CRD that is created in this operator, and here you can specify that which language you want to run. So right now this is Go, the version of the Golang, and the ID password, like what should be the ID password. So this password, you are asked to input the password at the very first time when you just open that particular environment, and the type of editor, in this case VS Code, and the extensions. And here I'm referring to the VS Code extension that you want to install as soon as or that should be pre-installed in your environment. And the database, which is Postgres and the Redis. These are the currently supported versions or databases that I have. So here you can see that we are able to run this program as well. It's a Golang program, and this is giving us the output as well. Now in this particular video, I'm not going to show you how exactly I created this environment, but I'll just walk you through the code implementation that I have done. And also to note that this particular environment, this is running on HTTPS with the help of, so here you can see that this is running on HTTPS. You can see the log symbol, but this is running on using these certificates, self-signed certificates that are issued by the cert manager. So in this particular operator, I'm using cert manager as well, that is going to issue the certificates for the endpoints that are going to get created on the fly for us. And here you can see that this is the endpoint on which this particular environment is running, but this endpoint will be different for every environment that you create using this particular operator. So there are multiple pieces in this particular operator. The first one that I already mentioned is basically the cert manager that we are using. Along with this, all these endpoints are exposed or via ingress, and in this case, I'm using Nginx ingress for exposing up all the endpoints. Let's go ahead and let me show you the Node.js environment as well. This is again a sample file that I have created just for reference. So here you can see that I'm giving the name as Node.js env, the language that I want to run Node.js, the version, the ID password, the VS Code, and the relevant extension that I want to install or want my VS Code to be pre-configured. And the other supported database that I want to use is Redis in this case. So I can just simply run this particular custom resource as well, which is Node.js env. And as soon as I do this, again, my operator is running right now locally. Here you can see my operator is running. And if I just show you the get pods, so here you will be able to see that this particular pod which is coming up, it's a database pod because we have specified the database as Redis. So Redis database will come up. and then the other pod, which is the VS Code server. So in some couple of minutes, this will also come up, and we should be able to access it via the endpoint. So let me do kubectl get ingress. So we should be able to see the ingress here as well. So this is going to be the ingress on which this particular Node.js environment will be accessible, right? So I can just simply open it from here. It will not open immediately, but here you can see that it is giving us the warning because the certificates that we are using these are the self-signed certificates. So I'll click on this proceed, and right now it says service is unavailable because the environment is still coming up. The pods are still, Node.js environment is still coming up. Meanwhile, this is coming up. Let's go ahead and see how exactly I implemented this particular Kubernetes operator. So first, I'll show you that the schema or the custom resource definition, how I generated. So if you go here, this is the types, the development environment types here, and here you can see that these are all the relevant properties that I specified in my custom resource. So here you can see the language, and again, if you see this particular piece carefully here, that in the languages I have put a validation. Let me collapse this. So here you can see that I have put a validation where the enum, it should be, the value should be a enum of type either Node.js, Golang, Python, Java, or Rust, right? So these are the relevant languages that this operator is going to support, and it's I'm here using the kube builder markers that are going to enforce the validations on the custom resource side. Then the version field is a string, and the ID is, so basically if you see the ID is coming from this object called ID config that I have specified below. So here you can see that yep. So here you can see that the ID config is again a struct, and these are all the relevant values that I need in this struct, right? Then there is a database section against which you can specify which all databases you want to run. So in this case, here you can see that I have defined again a enum for validation, and thus supported values are Postgres and the Redis. So the type can have either value as Postgres or Redis. And then there is another field called version, and here I am again using the kube builder markers for the validation, and the default value for this particular version field will be latest in this case if the user doesn't specify. Similarly, there is a dependency section as well that I right now am not using it, and then similar to it there is a section for the, I think, database we have already discussed, right? So this is how the overall structure of the custom resource definition is going to look like. And let's go ahead and see the controller. So let me collapse the functions here. Okay, so if you okay, let's try to understand the particular reconciler, because in Kubernetes operator, reconcile is the piece, or it's a reconcile loop that runs at a specified frequency or interval that we as a developer of the operator specify, right? How the reconciliation, at what frequency the reconciliation will happen. So in this case of reconcile, let's see how the reconciliation is implemented. So first we are checking whether that particular object that we are trying to create is already available or not. So here we are doing a get call on the cluster, and if that is not found, then we are simply returning the error. But if it is found, then we are moving ahead. Now we are checking if it is a delete request. So if it is delete request, then there will be a deletion timestamp field that is added to that definition. So if there is that field available, which means that we have made a deletion request. But if that field is unavailable, then it means that that it's a normal creation request or updation request, right? Then we are also checking for the finalizers because finalizers helps us in reconciling of the object. So we are doing the checking the finalizer as well, whether the object contains finalizer or not. And then we're simply doing the reconciliation. Now this particular function that you see, reconcile developer environment, this is a function. Let's go to this function. And in this particular function, we are doing all the relevant steps, right? So first we are ensuring that the namespace is available, like the namespace is created, right? So this particular functions, basically if we go to this function, this is going to check whether the namespace is there or not. And if the namespace is not there, then we are going to create the namespace on the fly. So here you can see that first we are checking whether the namespace exists or not. If that namespace does not exist, then we are simply going and creating up that namespace. So here you can see that we are creating up the namespace in case if that does not exist, right? Then comes the setup certificate part, and in this particular function we are going to set up the certificates that is going to make this request as HTTPS with the help of cert manager. So if we go to this particular function here, you can see that I'm creating a issuer. Again, these are the terms related to the cert manager. So in cert manager there is something called as issuer that helps us in issuing of the certificates. So here we are again checking if the issuer already exists. If that issuer is already available, then we skip that. But if the issuer doesn't exist, then we are simply going and creating up that issuer. So here also you can see that we are doing a get against that issuer. And if that does not exist, then we are simply creating up that issuer here. Here you can see all the details, like on what namespace it should be created and what should be the name of that issuer, right? Uh, let's go to that function again back. And then the next function is the provisioning of the development tools. Now in this particular function, we are creating up all the relevant tools and the scripts which are going to set up the environment. So here you can see that we have a script. Uh, Let me expand this. So this is a script which is installing up all the required packages. So assume that you want to run a Node.js environment, then this script is going to set up the Node.js environment for you, the VS Code extensions for you. And if you assume that you want to run Python as a as a tool in your VS Code ID, then it is going to set up Python and the relevant extension side. So here you can see that I have put various conditions, like the if condition, if the language is Python, then do these things. If the language is Node.js, then install the Node.js and the npm, right? And that is what we are doing in this particular script, right? And here you can see that here we are rendering up the scripts because it is a template, right? So we have to create the template, a file with the real value. So that is what we are doing here in execute function. Again, this is a built-in function that is coming from the templates package, right? So now this script is getting mounted as a config map to the containers, right? So all the pods. So here you can see that we are creating up this config map. So here you can see that the config map is getting created, right? And then we are mounting up that config map to the container. So I'll show you that piece as well. So again, here also we are checking whether that config is present or not. If that is not present, then go ahead and create it, right? Okay, let's go back to that function. And now the final function is to set up the VS Code. And in this particular function, we are setting up the VS Code. So here you can see we are creating up the persistent volume because the changes that we want to do, we want to make it persistent. Like what changes here I'm referring. So the changes that I am doing here, like the file that I've created, even if I restart, if my pod get restarted, the VS Code server gets restarted, the data should be still there, right? So that is where we are creating up the persistent volume claim. So I have created the persistent volume claim, and then I am simply injecting that script, the config script, as a post lifecycle loop, right? So in Kubernetes, in a Kubernetes pod, you can run certain commands or scripts either using pre-lifecycle hook or a post-lifecycle hook. So here I'm using the post-lifecycle hook, which means that as soon as the container is created or the pod is created, the script is going to get, or the command is going to get executed, whatever I've defined in the post-lifecycle hooks. So here you can see that this is a post lifecycle hook, right? And here I'm simply executing that script, which is going to get mounted as a config map, right? So here you can see that I'm executing this bash command against that script that we have defined. Then we are creating up the deployment, and this is a deployment of the VS Code server, and also there will be a deployment for the database as well, right? I think it is below in the code. So then we are also creating a service, and then we are also going to create ingress as well. Yep. So here you can see that we are getting up ingress. So here certain fields right now, since this is a POC or not a production ready environment. So I have hardcoded certain fields like the ingress class name here. this hard code, but this can come through the environment variable as well, or through the configuration. So here I'm creating the ingress as well, and that ingress is getting mounted or binded to the service that we created previously. So here you can see that we create this service. This is the service that we created, and this service, the ingress is getting bounded to this particular service. We're also creating the so when this ingress is getting configured, since it's a HTTPS based ingress, so here you can see that we are adding those annotations of the issuer, and that TLS certificate will be automatically, or the TLS related configuration will be automatically mounted to the ingress. Okay. Now, once the VS Code is configured, then we can set up the database as well. Again, database is also doing the same thing. This function is also doing the same thing. We are creating up. So if the database type is Postgres, then we are doing these things, and these are the environment variables that I want to set up. And if it is Redis, then we are setting up a different environment variables, right? And then we are again creating up the persistent volume claim, and then we are bounding this persistent volume claim to the database deployment. So here you can see that this is the database deployment, and then we are creating it, and then this is the services that we are creating, right? This is the service that will be associated with that particular deployment, right? So this is how this whole thing was, configured. I want to show you one more important thing here. Since you can see that I was using cert manager as well, and I was using the cert manager types as well, right? So for that, obviously, I had to use the cert manager packages. So here you can see that there will be a cert manager packages. You can see that these are the types and other functions that I am using of the cert manager. Now, one more thing I want to highlight here is that in order for my operator to understand cert manager, I have to add the schema of it, right? And how did I did that? So if I go to my main file, uh, so there will be a main file, yeah, main.go, and here, okay, I guess it's in the controller only. So if I go to the bottom where I'm adding them to schema, yep. So here you can see that this is the setup with manager function that is getting called. And here you can see that I am doing cert manager add to scheme. I had to do this because if I don't do this, then the operator will never be able to understand about the cert manager, and all the operation related to cert manager, they are going to get failed, right? So here we have to add that schema with so that operator has a knowledge of the cert manager, right? And in the main.go, let's see the main.go. So I made slight adjustment to the main.go. And the only modification that I did was the resource URL, because if you see these endpoints, if you see this endpoint as well, there is a endpoint, there is a suffix called developer env.adityajoshi.online. This is the suffix part, and all the resources that we are going to create, where I'm adding them as a prefix, right? So I need this detail, like what should be the suffix part here in this case, and that is what I'm getting here. So and I'm getting this as an environment variable. So if user is specifying this as an environment variable, then I'm using it. Otherwise, this is the default value on which it's going to fall back, right? In the similar way, you can pass other configuration as well, like the nginx class or the ingress class that I am passing, right? And all the other things that currently I'm hard coding, those can be configured via the environment variable or through the configuration, right? And this particular variable I'm passing in the my in the reconciler. So here you can see that I am passing this in the struct. So in the struct, I have added this resource URL string, and that is what I'm using throughout this particular reconciler, right? So since this environment is already running, let's see, we started up this Node.js environment as well. Let's try to, see if this is running. So here you can see that this is running. And now we have to specify the password. And the password was specified in this file, which is Node.js env. So if I just copy paste it, and let's see if this works or not. Okay, so here you can see that this is working fine. And let's try to, let's try to leverage the database as well, because in the previous demo that I showed you in the Golang one, we didn't leverage the database. So let's try to leverage the database as well. That's going to give us a true picture how the things are, interconnected. So I already have the, code for the Node.js. I'm simply going to, copy paste it here. I think kept it in the samples only. Yeah. So here, I'll just simply go ahead and run these commands. So this is going to initialize a Node.js project. So the Node.js project is, a folder is created and the project is initialized. Now I can run this command. This is going to set up all the dependencies. So there is a package.json which has a dependency of Redis, right? And now let's create a file called app.js. And this is a simple file which is doing simply storing up some data into the Redis and then reading out the data from the Redis. So here you can see that we are doing client.set. We are setting the key value, right? And then we are doing client.get the key, right? And then here you can see that this is the Redis URL. So in this case, since this is a Node.js based environment, so the service name is configured in that way only. Node.js -env database is the default service name, right? And I can simply install the Redis, and then we can simply try to run this particular example. Let's see if we are able to run I think we will have to initialize these things. So I can say let key is equal to 1 and let value is equal to maybe 100, right? Oh, I think these are already initialized. Let's make it let only, or let's don't initialize it. Okay, let's try to run this. Okay, it says Redis. Okay, I think there is some issue with this particular code, but now you get a gist. Like, I mean, we can simply connect to the database as well, but somehow this code is not working. But yeah, it works. Like I tested it previously as well, and that used to work. So going back to the our operator. So let's summarize. What exactly this operator is aimed to do. So this operator is simply you can use this operator to spin up the developer environment. And right now the supported languages that this operator supports is Golang, Rust, Node.js, Python, and Java as well. And then you can specify what all versions you want to run of those particular languages, and then you can specify the database password. Right now the type can only be VS Code. This currently supports only VS Code, but in future if there are we can think of supporting up other IDs as well, and the extensions as well that you want to come as a pre-built in this particular VS Code. So when we spin up this Node.js environment, we gave these two extensions. Let's see if these are available. So here you can see that these extensions are already installed. Like we didn't install these extensions; these were already here. Why? Because we have specified them here, right? So whatever extensions that you give here, they are going to get installed automatically for you. And then the database is Redis based on the whatever database you specify here. Right now it supports only two, Postgres and Redis. And even if I try to specify some different value, it's going to throw an error. Let's say maybe I give a different value called MySQL. It's going to throw an error. Why? Because so here you can see it's going to throw an error because we have kept the validation as that it should be accepting only Postgres or the Redis, right? And how did we specify this? We specified this in the types. So if you see here in the database spec, you can see that we defined the validations, and it can be either Postgres or Redis, right? So let's summarize the code as well. So in the code here, you can see, let's start from the main. So in the main, I am just getting up the resource URL value, value user can provide. He can provide in the form of environment variable, resource URL. And if doesn't provide, then this is going to the fallback value. Then we are calling the setup manager function. And inside the setup manager function, we are setting up the cert manager schema. We are adding that cert manager schema so that our operator knows how to deal with the cert manager. And then the reconciler is getting called. So the reconciler function, which is reconcile. So this is the function which is getting, doing the task of reconciliation. First, we are checking whether that objects exist or not. Then we are handling up if the object is getting deleted. We are adding finalizers to it, and then we are, doing up the main task, which is setting up of the environment. And here you can see that we are checking whether the namespace exists or not. If that doesn't exist, then create it. Similar thing for set certificates as well, because we want to issue the certificates via cert manager. That is what we are doing here. It's completely an optional step. Then we are provisioning of the development tools, setting up the VS Code, and then setting up the database side. So this is what the operator is doing in a nutshell, right? So the code for this is already available in the Kubernetes development repository. The link for that will be in the description. You can check that out. And if you have any doubts or any concerns or any questions, feel free to, reach out to me over LinkedIn, or you can just comment in the video description. I know that this was a very fast video. I was not able to code in this video because otherwise the video could have been, very long in this case. But I just wanted to show you and, or give you an idea that how you can build your own GitHub code spaces using the help of Kubernetes operator, right? So this was it for this lecture, and I'll see you in the next one.